Okay, in this session we can discuss about the data handbook usage. Okay, especially for the introduction to electrical engineering subject. The subject code is changed. That is BESCK 104B. Already you can know this one. Okay, remember there will be internal 50 marks. The external will be of 50. But the examination will be conducted for the 100 marks. The complete duration will be of 3 hours. Remember that the total 180 minutes will be there. Among that, you have to write the 5 questions completely. Okay, then the each question what you are going to attempt, complete full question, plan accordingly, then you can attend your answers. Okay, once you completed all the 5 questions, if the time is available, then try to attend the extra question also. Don't bother about it. Okay, keep this is in mind. Then now with respect to this, you must follow the first syllabus. Then according to that syllabus, you plan your preparation. Okay, the first module with respect to the introduction to electrical engineering, that is for the electrical sources, then general structure of the power system using the single line diagram. Then power generation, hydroelectric power plant, solar power plant, wind power plant, especially with respect to the block diagram alone. Then with respect to the DC circuit, Ohm's law and its limitation, Kirchhoff's laws, Kirchhoff's current law, Kirchhoff's voltage law, then analysis of series circuit, parallel circuit, and the combination of the series parallel circuit corresponds to that the numerical. You can concentrate. Then with respect to the second module, the fundamentals of AC. Okay, that is with respect to the voltage equation, then current equation corresponds to that of the waveform. Then definition for time period, frequency, amplitude, phase difference. Then definition of average value, RMS value, form factor, peak factor. They clearly mentioned here only the definition. But there will be a chance they will ask the derivation for the form factor. Okay, in my class I did that. Okay, that you can follow that. Then with respect to the voltage and current relation in case of pure resistance, pure inductance, pure capacitance. Then also you should be know about the concept of impedance, especially in case of the series RL circuit, RC circuit, RLC circuit. Then you remember in case of the AC network, there will be 3 powers. One is active power, reactive power, then the apparent power. Okay, the definition you can remember and the equations you can remember. Then concept of power factor. There will be 3 definitions. One is cos pi, R by Z, then P by S. Then with respect to the 3-phase circuit, the generation of the 3-phase power, then advantages of 3-phase power and its limitation corresponds to that the star connection and the delta connection. In that, especially you can concentrate on the relationship between the line and the phase quantities. But the derivations are not required. Keep this is in mind. Don't think on your derivations itself. For the what? The star and delta connection corresponds to the line parameter and the phase parameter. Then with respect to the model number 3, that is with respect to the DC machine, DC generator and the DC motor. Okay, in this, the principle of the DC generator, construction, then the derivation for the EMF equation, that is Eg equal to pi z np upon 60A. Then types of generator, okay, that is self-excited and the separately excited. In case of the self-excited series shunt compound, in that compound, again there will be a cumulative and the differential. In case of cumulative and differential, again there will be a short shunt and the long shunt. Those things you can remember. Then relationship between the induced EMF and the terminal voltage corresponds that the numerical you can concentrate. With respect to the DC motor, then principle of DC motor, then back EMF, what is the back EMF, what is its significance, then torque equation, types of motors. Okay, in case of time motor, types of motors also to remain same as which is there in case of the generator. Then characteristics of the DC motor, then corresponds that of the speed control. They clearly mentioned speed control corresponding to the armature and the field. Then corresponding to that which type of the motor, the series and shunt alone. The characteristics also be series and the sent. Then speed control is also be series and sent. Keep this is in mind. Okay, don't concentrate on the compound motor. Keep this is also be in your mind. Okay, don't concentrate on with respect to the speed control and characteristics of the compound machines. Then applications of DC motor corresponding to the series, corresponding to the shunt, corresponding to the compound. All these three motor application you have to remember. Then the numerical with respect to that. Okay, this is corresponding to what? The DC machine. Then with respect to the model number 4. Okay, this is corresponding to the transformer. Okay, and the three-phase induction motor. In case of transformer, what the necessity of the transformer? Necessity of the transformer is to increase the voltage or to decrease the voltage, and also to transfer the power from one circuit to another circuit based on the voltage level which to be required corresponds to that of the power which need to be transferred. Then types of transformer. Okay, that is the cell type, core type. Corresponds that construction of the single phase transformer. Then EMF equation, losses in transformer. Then variation of the losses in case of the transformer with respect to the load. Then efficiency, that is the output power to that of the input power. Then based on that efficiency, you need to concentrate on the numerical. Okay, this is mandatory, you need to remember. Then three-phase induction motor. Okay, there will be a major concentrate on the rotating magnetic field. Normally we'll call that into RMF. Okay, that itself is the what? The working principle of the induction motor. Then corresponds that the construction feature of the motor. Then there will be two types. One is squirrel case and slip ring. Okay, the slip ring is also be called as a phase wound rotor. Okay, these two types you can concentrate on the construction. Then definition of slip and its significance. Okay, corresponds that slip, then rotor frequency equation. Then you need to concentrate on the numerical. Okay, these things should be mandatory to prepare for your examination point of view. Then, with respect to the model number 5, the domestic wiring, what are the requirements of the wiring, then types of wirings. Okay, preferably they have mentioned here casing and capping. Okay, with respect to the casing and capping, which material you are going to use, whether you are going to use wood, whether you are going to use PVC. Corresponds that the wood casing and capping is also be there, then PVC casing and capping is also be there. For the temporary wiring purpose, we are going to use the preferably casing and capping. Then there will be a two-way control and the three-way control of the particular load. Okay, especially with respect to the lamp. Okay, then electricity bill, that is rating of household appliances like air conditioner, PC, laptop, printer, and etc. Whatever is to be present. Then definition of a unit. Okay, unit is nothing but 1 kilowatt of power to be consumed by the particular load for a duration of 1 hour. That itself is called as a 1 unit of energy consumption. That normally we'll call that as kWh. Okay, kilowatt hour. Okay, keep this is in mind. Then tariff. Okay, tariff is what? The rate at which the electrical energy to be paid. That itself is called as a tariff. Among that, you need to concentrate on preferably two-part electricity tariff. Okay, it means that one which is having a operating cost and the one which is having a fixed cost. Okay, this itself is called as a two-part tariff. Then corresponds that the calculation of the electricity bill for the particular domestic consumer. Okay, those numerical also you can concentrate. Then equipment safety measures. Okay, that is working principle of fuse, then miniature circuit breaker MCB. What are the merits and the demerits of the fuse and the MCB if you are using that is for the safety measure point of view. Okay, then personal safety. Okay, what do you mean by electric shock? Then precautions against the electric shock. Then what is the earthing? What is the necessity of earthing? What are the types of the earthing? Okay, there will be a two types majorly, that is the pipe earthing and plate earthing concentrate. Then other two types are also be available. Okay, that is rod earthing and the strip earthing. These two things also you can concentrate. Okay, the four types of earthing which are to be present, but the examination point of view, they might be asking you about pipe earthing or the plate earthing, preferably. Okay, all of it listening, Meena, raise your hand. Okay, thanks. Drop your hands. Okay, majorly you can concentrate on the syllabus. Okay, using this syllabus, you do your preparation. Okay, then notes we have provided. Refer our notes or the textbook what is to be available in the syllabus that you can refer. Okay, this textbook for your examination preparation front of view. Okay, these things what which is to be required as per the syllabus. Now we can concentrate on the data handbook. Okay, listen me carefully. Okay, once my explanation is completed, still if you are having any doubt, then you can ask me. Okay, here this data handbook I have said once you can go through that, mute by yourself. Okay, here. Okay, this data handbook will be given to everyone individually in the examination, like which it is given for the mathematics and the physics. Okay, this is with respect to the triple E subject. Okay, triple E courses. Okay, our introduction to electrical engineering also belongs to that triple E courses. Okay, they have provided the formula also. Make use of this formula to make the evaluation of the particular thing with respect to the power. Okay, with respect to the voltage, with respect to the resistance, with respect to the current. Okay, these are the basic requirement of the formulas based on the data what they have provided. Okay, this will be represented in the front page. Okay, which is to be get provided in your examination. Okay, first thing. Okay, as per the model number 1. Okay, that is they have provided the Ohm's law and its statement. Then along with that, these equations. 1 minute. Okay, then Kirchhoff's current law, its statement, and the equations. Then corresponding statement and the equations. Okay, then the equivalent circuits are also be provided. Okay, the corresponding to that they are given the equations. Okay, you can go through the same whatever the circuit is to be provided. Okay, next, this is for your reference point of view. Okay, so that they have provided all these details because you might be using this for the numerical solution point of view. Then the resistance in series. Okay, in case of the resistance, if those are connected in series, the voltage will be different across each resistance. That is the voltage drop, but the current will be remain same. The corresponds that the voltage equation, then the resistance equation, then the current evaluation equation they are provided. Then similar to that, whenever the series resistances are connected, they are going to consider with respect to the two resistance which are get connected in series. Okay, then we are going to make use of voltage dividing rule. Okay, that is V1 is equal to R1 divided by R1 plus R2 into V. That is V is what? The supply voltage. Then I need to make the evaluation of V1, that is voltage across R1. Then I need to make the evaluation of V2, that is voltage drop across R2. To make that evaluation, we are going to make use of these two equations. Okay, so that they are provided. Next, with respect to the parallel circuit analysis, okay, that is the reciprocal of the resistances which are connected in parallel. Okay, that effective resistance is equal to sum of individual resistances. Reciprocal is itself is the reciprocal of the total effective resistance. That will be represented here. 1 by R eq is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then corresponding to the current. In case of the parallel circuit, the current will differ. Okay, R1, that is I1, I2, I3, corresponding to the R1, R2, R3. But what happens? Voltage will remain same. Voltage won't be changed. But the total current evaluation will be done by V divided by the total effective resistance. Okay, to make that evaluation, you are going to make use of these formulas. But in this case, okay, the three different resistances are there. But if there will be a presence of only two resistances, then we are going to make use of the current dividing rule. Okay, that is I have used in my class. Okay, that might be Vinith sir also, then Ramya ma'am also. Okay, we are using that current dividing rule rather than that of the voltage dividing rule. I1 is equal to opposite resistance, okay, divided by the total resistance, that is R2 divided by R1 plus R2 into total current. Total current is what? I. Corresponding to the I2 is what? R1 divided by R1 plus R2 into I. Okay, this is how you have to make the evaluation of the I1 and I2. For that reason, they have provided this equation. Don't think that corresponding to that, what the data provided, according to that, you can make use of your formula. Okay, then power dissipated in the circuit. P is equal to V into I, P is equal to I square into R, P is equal to V square by R. Okay, this is the what? The power evaluation. Then energy evaluation. What the energy? That is power into time is itself is the energy. So that power into time you are going to get. But they are mentioned here as joules. Joule is also be a unit of energy. But with respect to the electrical, power is measured in terms of watt. The time is measured in terms of second. But generally the SI unit of energy is watt second. But the watt second is very smallest unit. Okay, generally we are going to use of watt hour, okay, or kilowatt hour. Okay, this is the what? The unit of electrical energy. Keep this is in mind. Okay, don't make use of representation with the joules. Okay, make use of watt hour or the kilowatt hour. Okay, if possible, the time is given in terms of second, make use of it. Okay, all of listening, raise your hand. Okay, thanks for response. Okay, this is the what? The energy equation. Next, this electromagnetism, this is not there. Don't concentrate. Don't waste your time to find your formula to make the determination, because this is not there in our any module. Okay, then this is also be not there. Don't concentrate. Okay, this is also be not there. Okay, what as per your syllabus, what which is to be present, those things only you can make use of it. Next, with respect to the module number 2, fundamentals of AC circuit and the single phase circuit which is to be present. Okay, they have given instantaneous voltage equation, instantaneous current equation. V is equal to Vm into sin omega t, I is equal to Im into sin omega t. What is this omega? Angular velocity. That is omega is equal to 2 pi f, which is measured in terms of radian per second. Then what is this f? That itself is the supply frequency, which is measured in terms of hertz. Then what is the RMS value? Okay, if you consider a resistance, okay, if that resistance is get connected to the DC power supply, okay, if this DC power supply is replaced with AC, okay, if the same amount of heat is transferred, then that itself is called whatever the current or the voltage is to be present with respect to the replacement of the DC power with respect to the AC. Then that value itself is called as RMS value. Okay, the same amount of heat has to be transferred with the replacement of the DC power supply with respect to that of AC power. Then that itself is called as a RMS value. Okay, corresponding to the voltage or corresponding to that of the current. What is that? Vrms is equal to Vm by root 2. Then what is Irms? Vm by, that is Im by root 2. Vm is what? Peak value of the voltage. Im is what? Peak value of the current. Then corresponding to the average value. What is the average value? Okay, if the replacement of this DC power supply with respect to the AC, same amount of charge has to be transferred. Then that value of quantity with respect to the voltage or current is itself is called as the average value. Keep this is in mind with respect to the alternating quantity. Okay, that is V average is equal to 2Vm by pi. Then I average is equal to 2Im by pi. Okay, then corresponding to the RMS value. Okay, that is 0.707 into Im. Corresponding to the average value 0.637 into Im. Okay, if it is voltage Vm, okay, corresponding to the RMS, corresponding to the average. Okay, these things you have to remember. Okay, these are what? The mathematical equations. Okay, these are with respect to the values. Keep this is in mind. Then form factor. Definition of form factor is what? The ratio of RMS value to the average value of the alternating quantity is itself is called as a form factor. Then you have to write this equation, then you have to mention this. Then peak factor. Okay, the peak factor is the ratio of maximum value to that of the RMS value of the alternating quantity. That might be with respect to the voltage, that might be with respect to the current. Okay, these things you have to remember. Okay, those formulas are to be provided in the data handbook itself. Okay, make use of these things, then you can solve the numerical. Then with respect to the pure resistance. Okay, if you are applying V is equal to Vm into sin omega t, then what is the current equation? I is equal to Im into sin omega t. Then displacement with respect to that voltage and current is 0. Why? Both are in phase with each other. Okay, for the pure. Okay, for the pure resistance, both voltage and the current are in phase. What it means? In phase means the minimum value and the maximum value occur at the same instant. Okay, that itself is called as a in phase quantities. Okay, then power is to be consumed by that pure resistance P is equal to VI. Okay, that is V is what? RMS value of the voltage, I is RMS value of the current. Okay, then you are going to get it. Okay, what is the power factor? The cosine of the angle between voltage and current. That itself is called as cos pi. Okay, what is the pi? Displacement which it is 0. If the cos pi is 0, that is pi is 0, then what is the cos 0 value? It is unity. Okay, what is the equation? P is equal to, in case of AC circuit. Okay, in case of AC circuit, P is equal to what? VI into cos pi. Okay, if you are going to get this itself is 1, what the power equation? P is equal to V into I. Okay, that itself is the what? The active power. Okay, make use of this okay, to solve your data. Okay, here they have provided V is equal to Vm into sin omega t, I is equal to Im sin omega t, Z is equal to R. Okay, that is V by I. Cos pi is equal to 1. Okay, this you can remember. This is the waveform. Whether they have mentioned the power waveform, not. Practice the power waveform with respect to this. Okay, they have given only the current and voltage. They have not mentioned the power. Practice that. Then pure capacitive. Okay, in case of capacitance, current will lead voltage by 90 degree. Okay, so that V is equal to Vm into sin omega t, then I is equal to what? Im into sin omega t plus 90. Okay, this is the what? The current and voltage equation if you apply it to a pure capacitance. Okay, then what will happen here? Okay, current will lead voltage by how much angle? 90 degree. So that voltage is 0. What the current? Current is maximum. So that the current is lead voltage by 90 degree. Okay, so that which is to be represented vectorically. Okay, V here, then I. Okay, what is the displacement angle? 90 degree. Okay, if cos 90, what is the value? 0. Okay, what is the P? P is equal to VI into cos pi. Okay, if cos pi is 0, what the power which to be get consumed by that element is also be 0. This is general concept. Okay, according to that, we can make use of this explanation. Then with respect to the pure inductance, V is equal to Vm sin omega t. then I is equal to Im sin omega t minus 90. Why? Because current will lag voltage by 90 degree. Okay, what happens? Voltage is 0, then current is negative. But in case of capacitance, which is positive. So that the current is lag the voltage by 90 degree. Keep this is in mind. Okay, this is called as out of phase. Why? The minimum values and maximum value will reach at a different value. Okay, different instances. Okay, that's why it is called as out of phase. Okay, current is having out of phase with respect to the voltage by an angle 90 degree in case of the pure inductance. These formulas also you can practice. Okay, but which it is also be there in your data handbook. Okay, if cos 90 is 0, what the power is to be get consumed by this inductance is also be 0. Okay, this is the common sense. You can remember. Okay, but derivation you can practice. Those are also be asked in the examination. Then for the series RL circuit, what happens? The power will be get consumed by the resistance, but the inductance not. So that the angle of displacement will be happened with respect to that only pi. Okay, so that V, if you are applying for the series RL circuit, V is equal to Vm sin omega t, the current will be Im sin omega t minus pi. Pi is what it is? This is the angle between the voltage and current. Okay, but it is an inductive. Then current will lag voltage by an angle pi. Okay, then what is the power equation here? P is equal to Vi into cos pi. Okay, this derivation also we have discussed in our regular class. Okay, to derive with respect to the power equation in case of the resistance and the inductance connected in series. Okay, this derivation you can practice. This is also be mandatory. Keep this is in mind. Corresponds that the waveforms are given. They will ask the power waveform. Corresponds that. Okay, go through that notes. Practice the same. Then with respect to the voltage, V is equal to I into Z, corresponding to the active power, Vi into cos pi or I square into R. Then corresponding to the reactive power, Q is equal to Vi into sin pi. That is also be equal to I square into XL. Then apparent power, S is equal to V into I. The power which is to be consumed is the active power. The power which is to be not consumed by the connected load, that itself is called as a reactive power. This also be called as a wasteful power. This also be called as useful power. Okay, this is wasteful power. Then this is useful power. Then what is the power? Apparent power. The power which is to be get supplied. That itself is called as a apparent power. S is equal to P plus JQ. That is the complex addition of active power to that of the reactive power is itself is called as a apparent power. Then power factor. Okay, power factor is cos pi, the cosine of the angle between the voltage and current, or the ratio of resistance to the impedance. As we know, okay, that is P is equal to Vi into cos pi. Then cos pi is equal to what? P divided by Vi. What is P? Active power. What is V into I? Apparent power. The ratio of active power to the apparent power is also be called as a power factor. These three definitions you can remember. Don't forget it all. Because those definitions will also be might be asking in exam. Then series RC circuit. Okay, there will be a resistance. Okay, the pure resistance is connected with pure capacitance. Then what happens in this case? If you applied V is equal to Vm into sin omega t, which will causes I is equal to Im sin of omega t plus pi. Pi is what? That is the angle between the voltage and current. Okay, as it is a capacitive circuit, current will lead a voltage by an angle pi. So that the leading current. Okay, corresponds that make use of the equation, that is V is equal to I into Z, then P is equal to Vi into cos pi, then Q is equal to Vi into sin pi, S is equal to V into I. Okay, this will be remains same for the RL as well as RC. There is no changes at all. But only thing is that to make the evaluation of the reactive power. Okay, I square into XC. Xc is nothing but the capacitive reactance. That is 1 divided by 2 pi Fc. Okay, with respect to the XL is what? 2 pi FL. That you have to remember. Then, for series RLC circuit, okay, for the series RLC circuit, okay, this is your vector diagram. Okay, there will be series resistance and the inductance and capacitance are connected in series across the voltage. V is equal to Vm into sin omega t. Okay, but there will be a 3 cases. XL is greater than XC, then XC is greater than XL equal to XC. Okay, corresponds that these formulas might be get changed. Okay, in my regular class I did that. Okay, go through that once. Then according to that you can concentrate. Okay, if XL is equal to, that is XL is greater than XC, then V is equal to Vm into sin omega t. Okay, then I is equal to Im into sin omega t minus pi, because the inductive reactance is more than that of the capacitive reactance, which will acting as a inductive circuit, so that the current will lag the voltage by an angle pi. Here current is lag the voltage by an angle pi. Okay, then Z is equal to what? R plus JXL minus JXC. Then V is equal to I into Z. Cos pi is equal to R by Z. Second case is what? XC is greater than XL. If the capacitive reactance is more than that of inductive reactance, then what happens? The series RLC circuit is acting as a capacitive circuit. Then during that capacitive circuit, what happens? Current will lead the voltage by an angle pi. Okay, so that V is equal to Vm into sin omega t, I is equal to Im into sin of omega t plus pi. This you have to remember. Okay, whenever the XC is greater than XL. Then what is V? Product of current and impedance. That is I into Z. Cos pi is R by Z. Then the one more case is there, XL equal to XC, but they are not mentioned. Okay, but in my regular class I did. That is Z is equal to R. Okay, because which it is acting as a pure resistance. Then current and voltages both are in phase with each other. Remember these vector diagrams. Okay, if not, this is also be get provided in your data handbook itself. Okay, to solve your numerical, you can make use of this. Okay, effectively you can solve. Then, with respect to the three-phase circuit, okay, in your syllabus, what they mentioned? Only the equations. Those you can concentrate along with network. Okay, VL is what? Line voltage. IL is what? Line current. V phase is what? Phase voltage. I phase is what? Phase current. What is Z phase? Impedance per phase. Pi is what? The phase angle between the voltage and current. P phase is called as active power per phase. Q phase is called as reactive power per phase. S phase is called as apparent power per phase. PH is represent per phase. Keep this in mind. Okay, P is active power, Q is reactive power, S is apparent power. Okay, what is star connection? Okay, if I considered R phase, this is starting terminal, it is finishing terminal. Okay, with respect to the Y phase, this is starting terminal, this is finishing terminal. With respect to the B phase, this is starting terminal, this is finishing terminal. If the similar ends are connected together at a one point and the dissimilar ends are get connected to the supply. Okay, this type of connection is called as a star connection. All of listening me, raise your hand. Thank you. Drop your hands. Okay, this is the what? The representation of the star. Okay, Z phase is represents phase impedance. Z is for impedance. Okay, PH is for phase. Okay, this is the star connection. Okay, which is to be get connected. VL is what? Voltage between any two phases. That is the line voltage. Voltage between any one phase and the neutral is called as phase voltage. Okay, wherever the two similar ends are, that is three similar ends are connected together, that point is itself is called as a neutral. At that point, voltage will be 0. Okay, then in case of star connection, derivation not required, but you can remember these equations. VL equal to root 3 times of V phase, IL equal to I phase. Then what is Z phase? V phase by I phase. These three formulas are to be required in order to solve the numerical. Okay, in your regular class I have used this, then I have solved some numerical. Practice those type of numericals. Next, with respect to the delta, okay, here with respect to the R phase, Y phase and the B phase. Okay, I will take start, finish, start, finish, start, finish. Okay, it means that dissimilar ends are to be connected together to form a closed loop. Those dissimilar ends are get connected to the supply or load. That itself is called as a delta connected system, because this is start and finish, start and finish, start and finish. All these are what? Dissimilar ends are to be connected together to form a closed loop. Okay, that type of connection is itself is called as a delta connected system. Okay, in case of delta connected system, VL equal to V phase. Then IL equal to root 3 times of I phase. Z phase is equal to what? V phase by I phase. Okay, these equations you have to remember. But these equations will also be present in your data handbook. Okay, this network is also be there. Practice that properly in order to solve your numerical. Make use of that effectively. Remember what content which should be present where. Then with respect to the three phase power related, okay, P phase is equal to what? V phase into I phase into cos pi. Not cos of cos pi, only cos pi. Okay, this is mistake is there. Don't write like this. V phase, I phase, cos pi. Then Q phase is equal to V phase, I phase into sin pi. Okay, the active power will be in terms of that. Reactive power will be in terms of VAR. What is VAR? Reactive volt ampere. Okay, S phase is V phase into I phase. That is V into A. That is VA. That is volt ampere. Then with respect to the line parameter, these are with respect to the what? These three with respect to the phase parameter. With respect to the line parameter, P is equal to root 3 VL into IL into cos pi. Then Q is equal to root 3 VL into IL into sin pi. Then S is equal to root 3 VL into IL. Keep this is in mind. Don't forget. Don't make VL into IL. This is wrong. Root 3 VL into IL is itself is S. Okay, if you are considering with respect to the line parameter corresponding to the voltage, corresponding to the current. Okay, remember this. This is also be very, very important in order to solve your numerical. Next. Okay, this is not required. This is not a part of your syllabus. Okay, these are not required. Next, with respect to the DC circuit, DC generator, practice the construction mandatory along with the derivation of the EMF equation. EG equal to what? Pi ZNP upon 60A. EG is generated EMF, P is number of pole, pi is flux per pole in terms of Weber, Z is number of armature conductor, N is speed of armature in RPM, A is number of parallel paths. A equal to P in case of lap connected winding, A equal to 2 in case of wave connected winding. They will ask you if the winding is connected in wave, what is the generated EMF? Then you are going to make the evaluation of generated EMF. If the same voltage is to be there, if it is connected in lap, what is the speed? They will ask. Okay, such type of numerical they will ask. First, you have to make the evaluation of generated EMF for the same voltage if it is connected in lap. What is the speed of the armature? Okay, like that of numerical, they will ask. Then corresponds that you make use of the formula. Then you have to solve. Next, Okay, here EG is generated EMF, V is terminal voltage, RA is armature resistance, RAC is series field resistance, RSH is shunt field resistance, IA is armature current, IAC is series field current, ISH is shunt field current, IL is load current, RL is load resistance, BCD is nothing but brush contact drop. Okay, as I discussed the types of DC generator at the beginning, series, shunt, and the compound. Okay, if the field winding is connected in series with armature, that itself is called as a series generator. Corresponds that the equations are provided. Once you can go through that equations in the data sheet. Then, if the shunt field is connected in parallel to that of the armature parallel, then which it is called as shunt generator. Okay, in case of compound generator, both the series field and the shunt field are to be present. But in that, again, there will be two types, long shunt and the short shunt. Okay, in case of long shunt, the shunt field is connected in parallel to that of the series field and the armature. That itself is called as a long shunt. Okay, in case of short shunt, the series field is connected in series with, that is the combination of shunt field and the armature. That itself is called as a short shunt compound generator. Okay, corresponds that the equations are to be provided. Okay, go through these equations. Practice. Okay, because directly you can use it, you solve. That is enough. Because in data sheet they are provided. Okay, but where it is present, you have to remember. Corresponding to the motor. Okay, they are represented with respect to the same. Voltage, current, number of pole, speed, flux, torque, shaft torque, armature torque, back EMF, EB. A is number of parallel paths. Omega is the angular speed. Then IAC is series field, ISH is shunt field corresponding to the current. IA is armature current. BCD is brush contact drop. Okay, RA is armature resistance, RSH is shunt field resistance, RAC is series field resistance. IA is what? The armature current. Back EMF, as in case of generator, EG equal to pi z NP upon 60A. In case of motor, EB equal to pi z NP upon 60A. There is no change at all. Keep this is in mind. Then the armature torque. What is torque? The turning or twisting force is itself is called as a torque. TA is equal to 1 divided by 2 pi, pi into IA, then PZ by A. Okay, pi is flux, IA is armature current, P is number of pole, Z is armature conductor, A is number of parallel paths. What the unit for torque? Newton meter. Then angular velocity, omega is equal to 2 pi into n divided by 60 radian per second. Then shaft torque is the total power in terms of HP multiplied by 746 divided by omega. Then you will get the shaft torque. To make the evaluation of shaft torque, you have to make the evaluation of the angular velocity. Keep this is in mind. Okay, why this 746? 1 HP is equal to 746 watt. Because of that reason, we are multiplying that is with respect to the 746. Then similar to that, shunt motor. Here, shunt field is connected in parallel to that of armature. That is the what? Shunt motor corresponds to that equations. Okay, those equations are given in the data handbook itself. Keep this is in mind, make use of it, then solve the numerical. Then series field is connected in series with armature. It is called as series motor. Then with respect to the short shunt, okay, here series field is connected in series with the parallel combination of the shunt field and the armature. That itself is called as a short shunt compound motor. Then long shunt is shunt field is connected in parallel to that of series field and the armature. That itself is called as a long shunt compound motor. Okay, corresponds that the equations they are provided. These equations you can practice. Okay, but which are to be there in the data handbook itself. Make use of it, solve the numerical. That is more than enough. Then with respect to the transformer, okay, the transformer is what? It is a static machine which will transfer the electrical energy from one circuit to another circuit. Okay, one is for primary. Okay, two is for secondary. That you have to remember. Okay, E1 is induced EMF in primary. E2 is induced EMF in secondary. F is supply frequency. N1 is number of turns in primary. N2 is number of turns in secondary. Pi m is maximum flux. V1 is primary voltage. V2 is secondary voltage. I1 is primary current. Then I2 is secondary current corresponding to the winding. VI is not WI is iron loss. WCU is copper loss. Okay, X is the fractional load. That is 1/2, 1/4, like that. Okay, V is the volume of the core. Then Bmax is the flux density at the maximum flux. Neta is efficiency. Okay, but which is also be using as a constant. Beta, then the thickness. Okay, but these are not required. Just to have a glance of it. Okay, which is required for the other subject. Then what is the EMF equation? Kindly practice the derivation. EMF equation of the transformer. E1 is equal to 4.44 F into pi m into N1. Okay, 4.4 F pi m into N1. That is for the primary. For the secondary, 4.44 F into pi m into N2. Okay, this you have to remember. Then they have asked one question with respect to the transformation ratio. Define the transformation ratio. That is N2 by N1, V2 by V1, then I1 by I2. Okay, this can be represented by capital K. Okay, condition for maximum efficiency. Okay, practice that derivation. That is whenever the iron loss is equal to copper loss. In case of that condition, the transformer efficiency will be maximum. Okay, which is around 98%. Then full load current evaluation. Rating of the transformer divided by voltage. Okay, we will get the full load current. Then with respect to the primary I1, okay, with respect to the secondary I2. Okay, for I1 divide by V1, for I2 divide by V2. That is with respect to the rating of transformer. Then efficiency of the transformer. Okay, I have also used the same formula. You might be remembered in my regular class. Okay, X into kVA into 1000 D into cos pi divided by X into kVA 1000 into cos pi plus Wi plus X square into WCU. Why this X? X is fractional load. Okay, half load or 25% of the load, 74% of the load. Okay, then hysteresis formula equation. Okay, then eddy current losses equation. Okay, these things you have to remember. There will be two losses. One is iron loss and the other one is copper loss. Okay, these two are types of iron loss. All of listening me now, raise your hand. Oh, thank you. Okay, with respect to the three phase, remember the synchronous speed equation. Ns is equal to 120 F divided by P. Okay, F is supply frequency, P is number of pole. Then slip, S is equal to Ns minus N divided by Ns. Okay, that is change in synchronous speed with respect to the actual speed, which can be expressed in terms of synchronous speed. Is itself is called as a slip. N is rotor speed or the actual speed. Ns is synchronous speed. Okay, F dash is equal to S into F. That is what? The rotor induced EMF frequency or the rotor current frequency. That is F dash. Okay, I am using that is as FR also. FR is equal to what? S into F. S is what? Slip. F is what? Supply frequency. Okay, this is not required. Okay, this is not in your syllabus. Don't concentrate. You leave all these things. What I am explaining, those things you can concentrate. Then, with respect to the domestic wiring, okay, there will be two-way control. This is the equivalent circuit, corresponds to that truth table. Where you will use two-way control? Where there will be a necessity of one lamp can be get control from two different places. Okay, there we can make use of this two-way control. Best example is staircase. Then another one is bedroom. Okay, in these two cases, we might be using with respect to the two-way control. And in case of the corridors also, they might be used. Then that corresponding to truth table, once you can go through that. Three-way control of the lamp. What it meant? One lamp can be get controlled from three different places. That itself is called as a three-way control. Okay, corresponds that the truth table will be get provided. The example is what? Which can be used in auditorium, okay, which can be used in function hall, which can be used in godown, okay, which can be used in large laboratory spaces. Okay, these are the what? The different application where we can make use of this three-way control. Okay, corresponds that the truth table. Okay, then tariff. They clearly mentioned two-part tariff. What is two-part tariff? Which is having fixed charges and the running charges. That itself is called what? Two-part tariff.